My name is Bob Shibley. I'm the Dean at the School of Architecture and Planning. Welcome to Hayes Hall. The building you're in is a landmark dating back to the 1860s. This particular core of the building you're in was designed by an architect, George Metzger. George was working on his first commission when he took this job. He was 17 years old. We say that only to indicate that we never underestimate what our students can do, and most of them come to us between the ages of 17 and 18. We're here to welcome you today and thank you for joining us in the Sandy to November conference. When Hurricane Sandy made landfall in October of 2012, more than 186 people were killed and over 600,000 homes were damaged, and the infrastructure across New York State was devastated. When Snowvember hit here in Buffalo in November of 2014, 70 inches of snow fell in western New York, causing 14 fatalities and numerous roofs to collapse. These two events are just two of many that suggest to us that climate is changing and that our buildings and infrastructure aren't up to the adaptation and mitigation tasks in front of us. So it's time to look again at all of the varying effects of the weather pattern changes and to go to work on the core mission of a School of Architecture and Planning in architecture and in the infrastructure that supports it. The symposium draws together academics and practitioners from the Northeast and Great Lakes regions to discuss the contemporary thinking in climate resilience application to New York State. The symposium will address questions like, how do built environment professionals respond to changing climate? How is the building stock adapting to climate change in New York State? And how is resilience being addressed by built environment professionals? We've been supported in today's endeavor by a number of organizations that we'd like to recognize. Our School of Architecture and Planning, and in particular, I'd like to call out Nick Rakovich, who you will see much of through the course of this, but not as much as you might imagine. He was up till the wee hours of the morning and with a new baby in his household today. We're also sponsored by and supported by and have in attendance today the New York State Energy Research and Development Authority, a Center for Inclusive Design and Environmental Analysis here in the school, the ASHRAE chapter, the Niagara Frontier chapter, our UB Renew Institute, which is the Research and Education in Energy, Environment, and Water, AIA Buffalo, Western New York, and the U.S. Green Building Council, New York State, upstate. Climate resilience is an important issue for the state of New York, Western New York, and our school. We have a number of research projects going on in this area and recent faculty hires to build on our strength. A task of this school, of every School of Architecture and Planning, really, is to look not just at what practice is today and how to do it, but to actually, in the hockey metaphor of the day, to skate to where the puck is going to be. And what we know from the dynamics of change in the climate, that puck is moving fast. And this conference is looking for where it's headed. We've had a number of alumni in a recent kind of opening of this building speak to us about the next most important thing for a School of Architecture and Planning about to celebrate its 50th anniversary. What's the next most important thing to do? And one of the themes that came through very, very strongly is what is our address to climate change and climate mitigation, and mitigation and adaptation of our facilities related to that. I'm excited to announce the School of Architecture is one of the first signatories of the White House Educators' Commitment on Resilience Design, and we plan to have studios and seminars on the topic over the next few years. And in some ways, this symposium is a continuation of what has been a multi-year exploration of where we need to be on the subject of climate change. Student work that you'll see on the walls are important to us because these students are the ones who have inherited the problem that folks my age have created. I start with a serious apology. We messed up. And there's a lot of change to occur as a function of those errors. One of our school's most important roles is to prepare this next generation of architects and planners to address these critical issues. We have very serious and helpful partners in this endeavor, among them Amanda Stevens, who is with us today from the New York State Energy Research and Development Authority. Amanda is a project manager in the Environmental Research Program at NYSERDA. There, she manages the program's climate change adaptation research projects. She's been with NYSERDA since 2006. Before beginning work at NYSERDA, Amanda was an intern in the Environmental Protection Bureau of the New York State Attorney General's Office. Please welcome Amanda.
Thank you, Bob, very much for that introduction. And thank you to Bob and Nick and the entire School of Architecture and Planning for acknowledging and addressing this issue. It's really key, and it's really great to see people coming together and starting to talk about this. I want to echo Bob's welcome and thank you again for attending. It's a pleasure to be here, especially without the need for snow tires. It's great. And it's wonderful to see so many people, again, interested in this topic. As Bob mentioned, I work at NYSERDA's Environmental Research Program. I manage a number of climate change adaptation and resiliency research projects. In 2011, we funded the ClimAid project, which created climate projections specifically for New York State, then looked at the impacts of those projections and potential response strategies. We did this for 8 different sectors across the state, everything from agriculture to energy to transportation. But one sector was conspicuously absent, and that's the building sector. Given the importance of this sector for New York, for both its size, variety, and impact on both the climate and on the people who inhabit those buildings, we realized that this sector really needed a chapter of its own. So entered Nick and his team from Buffalo. Their project is filling a gap in the original climate assessment by putting a much-needed focus on New York State's buildings. This symposium grew out of that project and is serving as one means of communicating the importance of that topic. So I'm just going to say, keep it short and sweet, and turn it over to Nick, who's going to moderate our first session. Nick Rakovich is an assistant professor at the University of Buffalo. At UB, his research investigates the intersection of energy efficiency, renewable energy, and adaptation to climate change. He also teaches courses on design, building mechanical and electrical systems, and was one of the faculty advisors for the University at Buffalo Solar Decathlon Project. Nick is the principal investigator for our project, Adapting Buildings for a Changing Climate in New York State.
So good afternoon. Thank you, everybody, for coming out here on a really beautiful day. We realized once we had set the date for this event, which falls in the time period between when Sandy happened in 2012 and in late October, and Snowember happened in early November, that we may be tempting the fates in setting a conference for this kind of day. What I didn't realize was that my wife was actually also going to give birth on the same day as the symposium. So when Bob said that I have a small child at home, the child is actually still at the hospital and probably going back there right after this presentation. So you'll excuse me for being maybe a little bit scattered in some of the presentation, but also in rushing around for some of these other things. Just before we begin talking about the project and presentation, I just had a couple logistical items that I wanted to go over with everybody just for the day of the event. The first thing is that this event is being recorded for posterity on these video monitors, and it's something that we'll be posting to YouTube on the university sites later. So just giving everybody fair warning, especially if you ask any questions, you may be recorded as part of that process. If you do, I know a lot of folks are working professionals and may have projects and things that are going on. So if you do have to answer a telephone call, just ask that you maybe go outside far away from this space, as sound tends to carry back into here. But also there's a meeting going on directly across the hall for the university as well. There are continuing education units available for all of the 3 sessions. So we have forms that will be out on a table after each one of these sessions for folks to sign. We have continuing education units for architects, for licensed PDHs for engineers, and then also for planners. So just find the correct sheet and make sure you sign in after each event if you want that, and indicate whether or not you need a certificate, and we'll be emailing those to you later. When nature calls, there are bathrooms available on this floor, although they're only kind of single bathrooms. So if you find those are locked up after each of these presentations, just head down to one of the lower floors, please, to use those. And I will say, as a historic building, there's only one elevator that goes all the way down through the building, and it's the one to this side in the space. We're going to be giving, in the next couple in the session here, 4 short presentations, and we just ask, because we're videotaping it, that you would hold questions till the end, when we'll call the speakers back up for questions. And the last but not least, something that Yasmin will talk a little bit more in her presentation. You may have seen the Post-it notes in the lobby, and we'd love to get your feedback about the project. That's a big part of things that we'd like to incorporate into what we're doing. So I'm going to just start briefly here and talk a little bit about a research project that Amanda's talking about, which is titled Adapting Buildings for a Changing Climate. Our focus is on New York State as an issue. My job in setting this presentation up, though, a little bit is just to give a little bit of the background. I think as building professionals, or people who are students who are going to go into the building professions, we're all really well aware of the potential impacts of buildings on the environment. How many folks have seen some kind of variation of this slide at some point in the past, right? It's a pretty common thing, talking about how much water buildings use, how much waste is actually produced by them, how much carbon dioxide emissions come out of the upstream and downstream impacts of buildings on the environment. And I think the architecture and engineering and planning fields have been great have really had a great response to this, pushing ideas of new zero net energy buildings in terms of reducing the carbon emissions from the built environment, or pushing even beyond that to create carbon neutral buildings so that our new buildings don't have any impact on pushing climate change forward. They really try to be neutral in the face of that, or even start to reverse that trend. But even though we've seen a lot of great buildings that have come online, like the Adam Joseph Lewis Center, which is at Oberlin College, which was one of these first zero net energy, zero net carbon buildings, we're facing a new challenge that we're really beginning to recognize, and is that we have to think about not only how we mitigate greenhouse gas emissions to slow the impacts of climate change, but also to think about how our buildings need to adapt to the expected changes in climate. And so I'm sure you saw after Hurricane Sandy a lot of the posters and photographs and things about these buildings, these types of buildings. Our students have actually selected some of the more telling ones out in the lobby that they've posted up on the wall. But how do we begin to respond to this? How do we prioritize certain strategies? How do we think about this as an issue? Is really something that's emerging as an important topic for our profession. And what's exciting to share today is some of our initial thoughts on this process. I love teaching. I teach actually my large lecture class in this classroom. When I've showed this image to my students, they were quick to point out that the DirecTV antenna on top of the house actually survived Hurricane Sandy. And they thought they then asked the question, why don't we build houses entirely out of DirecTV material? That's not something that we're actually going to talk about today. That might be a future research project that we want to take a look at. So when we ask, what kinds of natural hazards are we talking about? What do buildings need to begin to respond to? Well, really, this is a list of natural hazards that happen across the United States, with the exception of volcanoes. We have the potential for all of these things happening in New York State. So the question is, what do we need to begin to respond to? Really, buildings need to begin to respond to all of these things, maybe not volcanoes, although I recently found out on campus we have the ability to create lava and magma and set things on fire. So that also could be future research that we take a look at. Best thing to do is not to build on a volcano and just to kind of get out of the way of it. So these are all things that we're already well familiar with and thinking about as we design our buildings in the built environment. But I think the thing that's troubling is when you look at a subset of these hazards, these are all things that we expect may increase in severity with climate change. And the expected changes in severity for all of these issues is something that the life of our buildings will see. If you think about something like Hayes Hall, which was online in the late 19th century, it's faced a very different climate over its lifetime, and hopefully now with its renewal, it's going to last 100 to 200 years in the future. What is the kind of climate that it's going to begin to look at? How does it need to respond to some of these kinds of issues? How we start to understand the issues of climate change is primarily through climate assessments. I'm just curious to the audience, how many folks have heard of the National Climate Assessment or ClimAid before Amanda spoke about it this morning? Okay, so a lot of my students are holding up their hands. So one of the big issues is, this isn't something that trickles into our profession, but at the same time, as Amanda said, the assessments that have happened have not necessarily had a building sector in it. And I think the exciting thing about the project we're going to talk about here is we think that this may actually be one of the first statewide assessments to actually look at the building sector, and there's a lot of interest in how this rolls up into other state assessments and also the national assessment in the future. So if you were to pull open a copy of the National Climate Assessment or ClimAid, you would see these as some of the major sectors and chapters of those reports. And you can see, I think, pretty clearly that there are not buildings listed as part of one of these issues. But one of the things that's important for what we do, if you think about, well, what are all the sectors and things that actually tie to the built environment, it really is all of these. Buildings really are the hub where a lot of these different things come together, where we experience cascading impacts, cascading failures. So not only looking at our sector as one issue, but also looking at how it makes connections to all of these other topics is an important thing to keep in mind. So how do we begin to respond to climate change? I've seen a great way to describe it, and it's in a term of 3 R's. The first R being resistance. This is something that I think most people are familiar with and something that the Army Corps of Engineers tends to take on, which is really to create a barricade, create something that's able to withstand all potential future events. But I think one of the important things that Rosetta is certainly going to talk about a little bit later is when you have a system that is this tightly tied to its environment, it actually is probably the least resilient system for dealing with these types of impacts. But in many cases where we have historical structures, things like Fort McHenry in Baltimore, this may be one of our only options because it's not something that we're potentially able to relocate. Other kinds of things, other ways to begin to deal with climate change as an issue is to think deeply about relocating and beginning to move away from these hazards. I think we saw after Hurricane Sandy and certainly after Hurricane Katrina in 2005 that building in the same places where you have repetitive losses is probably not a good idea. But if you ever try to have this conversation in a community that, hey, we want to shut your community down, we want to move you away to a different location, you should be prepared to probably leave in an armored vehicle. Terry Schwartz, who's one of our presenters later, told me a really good thing to do when you bring up a difficult topic like this is to show something beautiful. So in this case, it's a beautiful Airstream trailer. The idea of relocation doesn't sound so bad when you have such a beautifully designed object, but in most cases, we're not talking about something quite that exciting. And the last thing, and really the focus of this symposium, but also a lot of conferences that are beginning to happen around the United States, is the issue of resilience. And the session, the panel that's going to happen immediately after this session is going to go into this in depth as a topic and see how different professions of landscape architecture, urban design, architecture, and engineering start to frame out this issue. And resilience has a lot of potential, I think, for how we design the built environment, how we begin to respond to some of these stresses. It doesn't have to be something that's completely an engineered solution. There's a lot of opportunity for beauty and great design in that. One of the questions that always comes up when we talk about resilience as an issue is, what do we need to prioritize? What buildings are important? I mean, the simple question is any building you want to have last through a climate event is an important building to begin to make resilient. But in the same time, not all of those systems necessarily need to be resilient right now. And thinking about which systems of a building are actually going to last the longest. So in the case of Hayes Hall, for instance, the building that you're in right now, a lot of the facade and the stonework and things like that have been here for close to 150 years. Those have really started to see a big shift. The orientation of the building, foundation, and so forth is going to last the longest. Maybe we don't focus on the things, though, at the bottom, like mechanical and electrical equipment and appliances, which we're going to cycle through over these long 80 to 100-year time spans. So not only do we think about buildings as a whole system, but we start to think about buildings, the building systems in it itself, and how those things begin to interact. And we'll talk about that a little bit more in some of the work that we've done. So the current research that we're going to talk about today, we have an integrated assessment that we've been working on for NYSERDA to do a literature review and pull together some of the key impacts. Yasmin is actually going to talk about that literature review, some interviews we did with building professionals, and a survey of folks in New York State. Mike is then going to talk about a resilient strategies document. So we've pulled together a book to begin to help practitioners with this issue specific to New York. Paul Ray is going to talk a little bit about some of the potential economic impacts of climate change on the built environment in New York State. Brendan Kelly, who is from LNS Energy Services, is going to talk a little bit about some of our preliminary work on energy modeling and how energy flows in buildings may begin to shift as we see changes in temperature. This is part of a long series, though. One of the key things that we're trying to do is disseminate these research results to folks. And so you're at the first symposium. I will say, though, that coming up, we're going to have a series of webinars and presented at other additional conferences. So hopefully this will just be the first check-in for everybody to start seeing this information. And we'll be posting most of this stuff to the website, which I think is where most people registered for this event. As Dean Shibley talked about as well, this is something that we've integrated into our coursework here at the University at Buffalo. So we have a lot of great work that's on the wall out here from our students. Can I just ask the students who have their work represented to just raise their hands in here? So a lot of them worked really hard to pull these boards and all of this information together. I hope folks want to go out and chat with them. They really did a lot of deep thinking that helped us with this project, and hopefully they're going to take it on as future future designers. Most of that work has been through a series of graduate studios and seminars, but also pleased to announce that we're going to have an online course that'll be available in the spring of next year. So for everybody who registered here, we'll send you more information about that if you're interested in that as a topic. So that was a lot to do very quickly. Just to give a brief framing and overview of the project, I want to turn it over now to Yasmin Okur, who is going to be talking a little bit about the interviews and survey that we did. Yasmin is a PhD student in our Urban and Regional Planning program here in the School of Architecture and Planning. Her interests include equity planning, transportation, and challenges facing refugee populations. We're very, very lucky to have her working on this project because she has prior experience as a lecturer in the School of Architecture and Design at the Jordan University of Science and Technology. She has a background in architecture, landscape architecture, and now is working on one in urban design. So, Yasmin, please.
Okay, thank you everyone. I'm Yasmin. I'm one of the research assistants in this project. And for my presentation, I'm going to talk about three things. First, I will give an overview of the Okay, you can't hear me. I'll come closer. I'll give an overview of the integrated assessment and its role in our project. I will talk about the stakeholder interviews, the qualitative data collection method that we did as part of the integrated assessment. I will go over the interview participants and their characteristics, the data analysis that we did, and some of the main themes that emerged from the data analysis. I then will move on to the online survey. Again, I will talk about the participants in the survey design and mention the survey results, and I will end by just a general discussion on the next steps for this part of the project. So what is an integrated assessment? A useful way to think about it, it is a tool. It is a tool that policymakers can use to guide decisions relating to climate change, relating to environmental issues. The way it does that, that's different from other types of assessment, that is combines the analysis of the causes and the impacts of a certain issue at hand. In our case, we're looking at the causes and the impacts of climate change on the building sector. It combines that with an analysis of the possible solutions and possible strategies that we can employ in order to address this issue. So what it does that is through the process, it combines two things: a technical assessment of the general information and knowledge and literature that we have on this topic. It combines that with input and perspectives from stakeholders and people related to the field that we're asking. So in our case, we're talking about building professionals, everyone who works in the building sector. So just thinking about that might give you a hint of how complex that might be. I will go on to the integrated, the stakeholder input part of the integrated assessment. The first part was the interviews. So over a period of 6 months, we conducted 42 interviews with different professionals in New York State. We try to make sure that we have fair representations of different views and perspectives. So as much as we like to talk to architects, we need to talk to other professionals as well. So we talk to people in the engineering sector, we talk to people in the construction industry, people in policy and in education, to make sure that we're understanding what people are saying when it comes to climate change and buildings. We also wanted to make sure that we're representing a lot of climate regions within New York State. So not only people in New York City. Even though there's a lot of great work done in New York City relating to climate change, we wanted to make sure we hear also from professionals in the Adirondacks, or professionals from Buffalo, or professionals from Ithaca, and different regions in the New York State. We analyzed the transcripts and the text we got from the interviews using NVivo. So it is a tool that we use to see if there are emergent themes and patterns coming out from what people are saying. And the main themes that were identified related to climate change perception. So how do people define climate change? What are the impacts that they're seeing? The vulnerability of buildings. So what makes buildings vulnerable to climate change? What are the adaptation and strategies that people recommend? Some of the challenges and needed resources. So climate change perception for the first theme. So this is the idea of thinking, how do building professionals define climate change, and how does it relate to the work that they do? It is this idea that there needs to be a shared understanding between different professionals, between the engineers, between the architects, on the importance of climate change and the need to address it. But one of the interesting points that was coming out of this theme was the idea of standard of care. So basically what it says is that it is our professional responsibilities as people working in the building industry to address climate change, that we cannot ensure that the buildings that we design or the buildings that we construct can be safe and can be comfortable in the future if we do not address climate change. So that connects to the idea of the standard of care that we need to apply. So as one of the participants says, is that this definition of standard of care that we are used to should and probably will expand in order to include issues of resilience and include issues of adaptation. Main impacts that the participant identified related to changes of temperature, things relating to precipitation and flood, how can we apply flood prevention methods. But the most important thing that came out and that emerged is that we need to make sure that there will be a variety of impacts across the state. So some place will be warmer and some place will be colder, and professionals need to know that. They need to know the region that they're working in. Another impact that was identified was relating to termite damage, so things that maybe impacts that people are not familiar with. So we might think of temperature, we might think of flooding, but something as termite damage in some part of New York State might not be familiar for us. So we also need to raise awareness of impacts that people might not know much of. vulnerabilities. So this is a discussion on what makes buildings vulnerable. Some of the main factors that were identified related to building age. There's a lot of old buildings in the building stock in New York State. A lot of them were built using obsolete and outdated building codes. Building materials, as much as an architect myself, I think glass facades look really cool, but they might not be the best option if we want something that's climate responsive in the future. Thinking about vulnerable populations, so the elderly, children. In this case, something that was mentioned a lot is looking at low-income groups. So not everyone has the resource or access to air conditioning or heating units. So how can we as designers and building professionals address that issue? And of course, building location. The most simple thing that we can think of is buildings that are near or in proximity to floodplains. So how can we address that and go forward from there? So it's important to know the locale and know the region that you're working in before you actually start responding or addressing climate change issues. Some of the response strategies that people were talking about related to flooding measures, related to power and power outage, and this was brought up a lot, especially when they were talking about Hurricane Sandy and how a lot of the houses were unlivable because of the power outages. So how can we as designers build buildings that might be able to, that might be livable if there is no power? And utilizing things like passive design. An important note that was mentioned was that we need to make connections and we need to collaborate with building professionals in other states. So looking at other people, how they addressed termite damage, how they addressed hurricanes, things that they might be more familiar with than we are, and how can we share knowledge with each other. Challenges, this was the most popular topic of all the questions. I think we can easily understand why that is. If each one of us thinks, okay, I was giving a project to design and build that should be climate resilient and adaptive, and you were asked to list the challenges that you might face, the list probably will never end, because there's so many things that can go wrong, so many things that can be a barrier to you. And some of the things are related to complexity of climate change. There's so many factors going in, things related to the localized impacts that I was just talking about. The codes are big problems. They need to be worked out. Expertise. Do professionals have the expertise to deal with this? Is the education we're getting enough? Money. Of course, without money, we can't do anything, unfortunately. And then political will. We need that in order to get public support to do the things that we want to do. And without leadership, really, we can't do anything. And then I will go into the online survey. So the online survey really, the design of the online survey was moved by the results of the interviews and by the patterns that we were seeing in the interviews. We were lucky enough to get 286 participants to complete the online survey. 98 of them were from the architecture profession, and around 30% were from Western New York, so the Buffalo area. And we had some kind of fair representation from other sectors and other regions. Unfortunately, not as much from the Adirondacks. So if you're from the Adirondacks, we would love to hear from you. Some of the survey results related to climate change impacts. Because we had a bigger sample size, we were able to see differences that were emerging between different climate regions, looking at climate adaptation work, challenges, and motivation on why people are doing climate adaptation. So an example of the climate change impacts that we were able to notice the differences between regions. So on the left, you have the top climate change impacts that building professionals identified as important for the building sector, and that's in Western New York. And on the right, you have New York City. And we were really glad to see that there were differences. So professionals are able to identify that there's differences in the impacts that they need to address. So in Western New York, we had issues like winter weather, which is not a surprise, snowfall, flooding, ice or hail damage. In New York City, they had identified flooding, sea level rise, issues with hurricanes. We did have similarities relating to heat waves, and that can be understandable if we think about the issues facing urban centers and heat island effects. But what's also interesting, if you look at the termite damage, which was 2.5 in Western New York and 0% in New York City. And that tells you that really some of the impacts that people should start looking at, they're not identifying. And it guides us that we need to raise awareness on those impacts. Only 48% of the survey participants have done climate adaptation work, which is not a lot. So adaptation is not happening. And when we asked them to elaborate on the nature of these projects, they mentioned architectural design, they mentioned building energy modeling, and they mentioned building performance evaluation. So that kind of hints to us that there might be a confusion between what is adaptation, what is mitigation, that people are seeing energy efficiency and strategies that reduce energy as adaptation, when we know that those are separate things. And what's even more surprising is that 50% of the, over 50% said that they have the expertise to do that. So either they're confusing adaptation with mitigation, or there are some challenges that they are facing that's stopping them from doing the climate change work that they should be doing. And some of the challenges that they mentioned, similar to the interviews, the money, political will, skepticism. Unfortunately, there are still some climate change deniers out there. Leadership, uncertainty, things like time constraints. When someone is working on a project, they have a time limit, there's a timeline, and engaging in climate adaptation is really time constraining. It takes a lot of work, a lot of research, so they might not have the privilege to actually do climate change work. And when we asked them what was the main motivation for those who actually did climate change adaptation, a lot of them talked about preparing for the future, trying to reduce the impacts of these hazards, and trying to promote urban and sustainable development. And a lot of them relied on professional organizations, so things like the AIA, state agencies, and educational institutions like UB. So that tells us as a team where we need to go in order to disseminate our results and our projects in order to make sure that the strategies we're developing reach out to people. So what we're doing now is we're finalizing the integrated assessment. We have a first draft of the interview and survey results. We hope to be done by the end of the year. We would like, well, this is still an ongoing project, so we would like some feedback on 4 questions. So how can buildings be more resilient to a changing climate? Are there any barriers to addressing climate change in your work? You can think of that as a professional and as a student for your design project. What resilience strategies are important in New York State, and what climate change impacts are the most important? So those questions are pinned up in the hallway next to our room. So in the break time while you're having coffee, we'd really appreciate if you just give us some ideas on what you think relating to these questions, so that we were able to develop our project even more. Thank you.
Okay, so next up is Michael Tuzo. Mike is a dual Master of Architecture and Urban Planning student here in our School of Architecture and Planning. Prior to working on this project, he worked for the City of North Tonawanda and their engineering department. In the role, he was responsible for their project design, development, observation, and documentation for several small to middle-sized infrastructure projects. He earned his Bachelor of Science in Architecture from UB in 2014, and he's going to be talking some about some of the resilience strategies that we pulled together. Hopefully something is a good resource for the professionals here in the audience. So, Mike, turn it over to you.
Hello, thanks, Nick. My name is Mike, and I'm going to be talking about the Resilient Strategies document. And this is the part of our research that is looking to bridge the gap between the climate science and climate adaptation. And so our Resilient Strategies document serves as a conduit of information to assist both professionals and non-professionals as they look to improve resilience in their building design and building adaptation. So to start off, in their climate adaptation guidebook for New York State, NYSERDA included this eight-step adaptation assessment process, which jumps back and forth between identification, prioritization, and evaluation to create this cyclical process for effective adaptation. And the reason I bring it up is that we find that our Resilient Strategies document kind of focuses on the first half of this process, where we're identifying and prioritizing hazards in New York State. We're using this understanding to select and identify strategies that can help respond to these issues, and then prioritizing those strategies in a comprehensive document to disseminate this information to both professionals and non-professionals. So my outline will identify exactly that. We'll look at some of the climate hazards in New York State. We'll prioritize those and identify some strategies, and then I'll talk a little bit about the actual document as well as some conclusions from the process. So to begin the process, we asked the critical questions of what are these impacts of climate change, and where, when, and how can we respond to these impacts? And the critical references that we looked at were was the NYSERDA ClimAid report and the Division of Homeland Security and Emergency Services State Hazard Mitigation Plan. And what these two documents did is, as Amanda mentioned before, is they kind of outline how climate change is impacting New York State specifically, and we're taking that a step further by looking at how that's impacting the building sector in New York State. And what we found from this analysis is that the impacts, there's great variability in the impacts that climate change has on the building sector. From the name of this symposium, From Sandy to Snowvember, really outlines quite a wide variety of impacts that we've seen on our building stock. In Hurricane Sandy, we saw fire, wind, and flood significantly damage buildings in downstate New York. And for Snowvember, we saw things like power outages, extreme snow loads, and and ice dams again create significant damage on the building and the building stock in Western New York. But not only is there extreme variability in the storms and extreme diversity in the hazards that we're dealing with, but there's variability across the state. We used data from the University of South Carolina's Sheldis database to quantify and spatialize these hazards and where they're happening across New York State. And what we found is that there is it's not uniform, these impacts across New York State. What's happening in downstate is very different than what's happening in upstate, as Yasmin presented, that we kind of gathered from the qualitative analysis, but now we start to see it here quantified on maps. So we see here two hazards, flood hazards and hurricanes. Both are consequences of climate change. And then we also have severe storms and winter weather hazards. And for those of you that are familiar with geography or the geography of New York State, we start to see how some of these hazards align with the geography, specifically in the winter weather hazards. We really see the role that the Great Lakes play in the climate change impacts on New York State, and then also how sea level rises and hurricanes affect downstate New York. So we see this variability. So the question then becomes, how do we approach this? How do we make suggestions on how to respond to climate change? And fortunately, for many building professionals, we already have lots and lots of strategy documents and guides to look at to provide guidance. And so to start off our Resilient Strategies document development process, we looked at these documents to extract strategies and to synthesize how this information is presented. So a lot of these documents are prepared by professionals, and what we found is that those documents, it mostly then would appeal to those professionals. So we had a lot of situations where it's an architect writing for an architect or a planner writing for a planner. And while this achieves a certain level of detail where we have some continuity amongst the fields within the building sector, we can start to see how this isolates information and how this prevents certain key information from reaching a wide audience. And some of the barriers that were identified from the qualitative analysis was that lack of accessible information was one of the things that's restricting climate resilience in practice. And so when moving forward with the Resilient Strategies document, we wanted to keep in mind that resilience is both a professional and a non-professional effort. Climate change is impacting everyone, is impacting all buildings, so we should make this information accessible for all. So the Resilient Strategies document that resulted from this is meant to serve as a conduit of information, again, for allowing both professionals and non-professionals to access climate resilience information so that they can apply it to their own projects. We are attempting to appeal to multiple audiences in order to maximize the accessibility of this document. And the document breaks up resilience into 26 strategies that we've identified from the documents that we reviewed. And in this document, the term strategy serves as an umbrella term that helps guide resilience efforts. And what I mean by that is that the strategy is like a specific or is a particular field within resilience, and there's tactics that fit within that umbrella. So if we look at, for example, strategy number 9, building flood protection. Building flood protection is the strategy, and things like flood-resistive materials, sewage backflow preventers, and moisture sensors would fill in as tactics within that strategy. So if we look at a sample strategy layout, each strategy within the document has a 2-page spread that presents this information in text format. And so if I take a step closer and we look at the header includes quick access information. So I talked at the beginning of the presentation about the hazards that we're dealing with as a result of climate change. And those hazards are right here in the middle where we're saying building flood protection, in most cases, will act to address these hazards. And because of the SHELDUS information that we have, where we could locate where these hazards are happening in New York State, we can start to suggest locations within New York State where these strategies might be most applicable. So we've identified the strategies, and now we're prioritizing where they can be applied in New York State. And then also within the header, we have a list of the tactics that are included within that strategy. And those tactics are then, the strategy and the tactics within are explained in depth within the body of the document. And so we provide for you a description which talks about the strategy in the context of climate change and how it's addressing the specific hazards in New York State. I'll talk about multiple audiences on the next slide, but we also have example case studies that talk about either a situation where this strategy would have been applicable, or a case study example of where this strategy was applied and it was effective in responding to negative impacts. The most important part of the Resilience Strategies document are the links. So I apologize. Oh, the slide. I'll go back to the whole thing. So I apologize if it's a little fuzzy, but you can see in the text that there's blue links that are within there. This document, again, serves as a conduit for information. So all of those links that are included within the text are links to existing strategy documents, links to existing academic reports, homeowner checklists, anything that can help build or help spread knowledge of resilience within this strategy. So each strategy, all 26 strategies average between 23 and 24 links, which means that over 600 sources of information are referenced in this document. So Krista Macy and Nate Heckman had a wonderful summer digging through a lot of these documents and putting them together. But what we've done with this document is we brought all of this information together and we've presented it. We have 3 different audiences. We have owners and operators, policymakers and planners, and architects and engineers. And the point of separating this out is you can go into this document, get the information you need, find that focus, and then dig deeper with the links. So the way that these sections are written is that an owner and operator is presented with the information that they could use to improve resilience. A planner and policymaker presented with their information, an architect and engineers presented with their information. And this helps us disseminate that information and get the research out, the research that already exists, out to practitioners. So in conclusion, the process of developing the Resilience Strategies document, we identified the climate hazards and the impacts that we're seeing in New York State, and we prioritized them and located them across the state using data from SHELDUS. We identified and characterized the adaptation strategies and prioritized them within the Resilience Strategies document. And then finally, all of this was in the effort to move from theory to practice. We wanted to make this information accessible to both professionals and non-professionals in the field. And so just in conclusion, we currently have a full draft of the document complete that'll be reviewed by the advisory committee over the next couple weeks, and we hope to also have that done by the end of 2016. And all those that registered for the event, we will be sending a digital copy of this document for you to use in your everyday practice. So thank you. I'll pass it back to Nick.
Thanks, Mike. So our next presenter is Paul Ray. Paul Ray is a project manager, research, and analyst at the University at Buffalo Regional Institute. His main areas of expertise are in economic development, impact analysis, strategic planning, and transportation. He draws on also a multidisciplinary background, which is kind of a theme for the members of our team. So he has a background in civil engineering, economics, and urban planning. And he has a lot of experience working in both the transportation and construction fields to look at these issues from a multidisciplinary perspective. He has a Bachelor of Science in Civil Engineering and a Master of Arts in Economics and a Master of Urban and Regional Planning, all from the University of Buffalo. So please join me in welcoming Paul Ray.
Thanks, Nick. So what we decided to look at for this part for the economic impacts is twofold. We decided to look what happened in the past in New York State. This goes back to 1960. And in the future, how prepared can the state be, the state's building sector be, since we're talking about resilience here, dealing with these impacts. So if you look back to 1960, there's been several events. These aren't just one-off events that happen once in a while, like they would with maybe hurricanes. There are severe storms, winter weather, flooding. All this kind of happens throughout time pretty frequently. Obviously, severe storms happen more often than flooding and winter weather, and of course, hurricane as well. Some of the hurricane data that we got comes from FEMA and not necessarily Sheldis, which was our main source of this. So we're only really considering Hurricane Sandy in this process. But if we look at costs over time, they're a little less variable, and you see these spikes over time. So these major events kind of come through, and those are our major cost impacts on the building sector in New York. Of course, Sandy isn't on here, and the biggest event we have is $2.6 billion for flooding. So this is total throughout since 1960. And then our next biggest is $1.24 billion in a severe storm. And then we look at Hurricane Sandy, jumps all the way up to $10.6 billion. So this one obviously dwarfs the rest of them, but that's not to say that the other ones are not as important, because they are happening more often. So if you look at the building stock across New York State, we see that about 90% of the building stock is estimated to be about residential. So 5.28 million buildings across the state. But the non-residential buildings tend to have a little more value, as we know. Things like commercial operations, industrial operations, obviously, are higher in value and have more square footage per building. And we're looking at about $2.34 trillion in value in 2004 across the whole state. Now, where these buildings are matters. Obviously, most people that are familiar with New York State know that most of the buildings are downstate. About 60% is upstate, 40% is downstate. Most of the density in buildings tends to be located in the I-90 corridor from Buffalo to the west and Albany to the east, with Rochester, Syracuse, Utica, some other smaller cities in there. Binghamton in the southern tier also has a little higher concentration. But for the most part, fairly low density in between these major cities. Closer look at New York City. Like I said, 40% of the buildings in the state are estimated to be downstate in New York City and Long Island, and that's about 2 million buildings. Now looking again at costs over time, these are the total damage to buildings in New York State. That big orange chunk is mostly Hurricane Sandy and a couple other handful of hurricanes. As you can see, that dominates everything still, but $4.3 billion is still some big impact numbers over the past 50 years that has happened in the state, and certainly something we have to plan for in the future. If we dig in a little deeper to see where these things are happening, these are by climate regions in New York State. Looking at flood damage, most of the flood damage, or the highest flood damage to buildings, has happened in the southern tier. There is a comparable number in East Hudson and Mohawk River valleys, but if you look at the actual building stocks in both of those regions, southern tier has a lot lower density of buildings than East Hudson. East Hudson has some major metropolitan areas like Albany in there, and going all the way down to New York City, so there's a lot of density in there. So southern tier is certainly impacted a lot greater by floods. Looking at severe storms, kind of a similar story here with the Catskill Mountain, West Hudson River Valley region. That region has a lower density of buildings. It has about, I believe, 8% of the building stock in New York, but it has the highest building damage due to severe storms. Winter storm damage, as we saw from Mike's slides, we know that a lot of the winter storm damage happens along the Great Lakes, especially directly east of the Great Lakes. These figures, obviously, Western New York has a big impact. Across the board, these impacts tend to be lower than some of the other flooding and severe storms. Maybe one surprise is the Tug Hill Plateau has a little lower damage, but that is mostly a function of the actual number of buildings that are in that region. And no surprise here that the hurricane damage downstate is much greater than everywhere else in the state, and it sounds like practitioners are really thinking about that in the downstate region as opposed to here in the upstate region. So revisiting the total building damage again, we see New York City and Long Island obviously have the greatest impacts on building damage, followed by East Hudson and Catskill. But if we divide the actual building damage by the total value in these regions, we get a very different story. So as you can see, New York City, the damage only accounts for 0.8% of the total value, whereas something like southern tier accounts for 3.3% of the value, that is the damage that is done to these buildings. Similar story for Adirondacks and Catskills. So this really, you start to see a trend here where regions that may not have a strong central metropolitan area may not have the ability to respond to these storms, and they have a lot less value in buildings, so they can actually be impacted a lot greater. So now that we know where the damage is, we want to look to the future and say, how can we mitigate or become more resilient in these regions? So two ways we looked at this. We wanted to say, what is the adaptive capacity of each one of these regions? We looked at two measures for this. This is the regional construction capacity. So it says per square foot, how many construction firms do you have, and per square foot, how many construction employees? Certainly construction employees and firms can travel across regions very easily, but if they are rooted in the community, they can respond quicker, and they have more knowledge of the local hazards in those communities. And then we looked at if there is mitigation or recovery in these regions, what is going to be the economic returns? Well, certainly, if you're doing any kind of construction in an area, you're going to get kind of spin-off activity from those construction activities. So taking a closer look at the square feet per construction firm on the top there, these are ranked, these regions are ranked by the highest square feet per region. So obviously New York City and Long Island is on the top. So a higher number would indicate that you have less capacity. So this says per firm, Southern Tier has about 486,000 square feet to be responsible for if they were going to handle mitigation or recovery within their region. So this starts to tell that similar story that maybe some of the more rural or less populated regions Southern Tier and Adirondack Mountains may not have the capacity, or they may be impacted greater than places that downstate or, say, Western New York are. Similar story for construction employees. Southern Tier has about 91,000 square feet per construction employee, and Adirondack Mountains has about 75,000. Maybe more telling is the firms, because it's a little harder for firms. Certainly they can travel across regions, but they tend to be a little more rooted in their region than the actual construction employees, which can very easily travel across regions. Looking at regional economic returns, these are the same way. These are ranked from the top to bottom as building square feet is the greatest at the top. New York City and Long Island are at the top. And what these numbers indicate are a indirect economic multiplier. So if you're going to do any kind of mitigation or recovery in these regions, what would be the spin-off activity that comes from that construction spending? So that's to say, just to give a quick example, let's say Tug Hill Plateau gets a grant, federal grant to do mitigation on, say, some municipal buildings. They take that grant, they hire a construction contractor. That construction contractor pays employees to come out and do these retrofits to buildings. So that, say they get $1 million contract, they pay their employees. That employee may be on the way to one of the municipal buildings that they're retrofitting, stops at a coffee shop. They buy a cup of coffee. That money then in turn goes to the owner of the coffee shop, and the barista gets a paycheck and a tip. So then that barista goes out, and the coffee shop owner goes out, goes to a local movie theater, and so on, so on. This money kind of reverberates throughout the economy until it eventually leaves when someone buy something from Amazon Prime, and it goes all the way out of the region. So that's what these numbers mean. So for example, in that Tug Hill Plateau, if you're doing work on construction, residential construction, for every dollar that you put into the economy, you're going to get about 58 cents of additional return, additional output in the regional economy. So this is important to know that if you're spending local money, there's just local money moving around your economy. But if you're getting grants, if you're getting recovery money from outside, that's really important, because that could actually end up boosting your economy in the end. So mitigation strategies could certainly take this into consideration, saying, well, we're doing mitigation, which is great. We're going to have savings in the future, but we're also kind of stimulating the local economies in these regions as well. So coming to some conclusions, I think a common theme here is the impacts are certainly not evenly distributed when it comes to the number of events and certainly in number of dollars. And I would say certainly in the way that they impact the regions and the building sectors within these regions, the ones that have lack of access to supplies, construction firms, employees that are willing to work on mitigation and recovery are not evenly distributed around the region. Regions without a strong localized metropolitan area certainly could be a little more at risk in the future and have been in the past. And where the money comes from is important. Like I said, local money just spent in mitigation and recovery doesn't boost the economy, but there is potential for outside money to come into these economies and really bolster some of the economic activity. And maybe the biggest finding I think we found out of this is that lack of in-depth data has kind of limited some of the thinking on what the possible strategies could be in economic terms in the future. So partnering, I think, in the future with real estate agencies, the real estate industry overall, and insurance could really open up, I think, some avenues to data to find out where the buildings are, how they're constructed, how much they actually cost on either a building basis or census tract basis. So I think there are some new frontiers to kind of look at as far as getting data, so we can have really strong strategies moving forward in the future. Thank you.
All right, we're in the home stretch for this session. So the last presentation that we have as part of the project is from Brendan Kelly. Brendan is a Director of Energy Modeling and Energy Audit Services at LNS Energy Services from Albany, New York, and he's been there since its inception. He has more than 18 years of engineering experience, with 13 years of those working in the energy conservation field. He's managed many technical assistance and evaluation projects for small commercial, municipal, large construction, and industrial clients. He is a AEE certified energy manager and lead accredited professional and ICC commercial energy inspector. He's also a member of ASHRAE and the vice president for the New York State Capital Region Association of Energy Engineers. Brendan's going to be talking a little bit about some of the ongoing energy modeling work that we're doing as part of this project, so please join me in welcoming Brendan.
Thank you, Nick. My pleasure to speak to you all today. So this is, we're sort of in the preliminary phases of our work, so we're certainly open to suggestions at the end of this. But to kind of go over what we're working on and sort of the plan for energy modeling and the resiliency tests. So we're looking at the impact extreme weather has on building models, and we're using 5 building types in eQuest that we previously modeled through the NYSERDA New Construction Program. And we're looking at a larger, the larger building stock, where we have more buildings that are in New York State, and we are looking at a package minus approach, which is a typical approach that you might see when analyzing a building with measures, with the energy conservation measures. So we're looking at the energy use, demand impacts, and interior air temperatures. And we're looking at locations that align with the NYSERDA climate study. So next on to the weather data that we're using was provided by Weather Analytics. So we're running 4 types of weather in 5 locations. And some of this weather data, like the extreme weather meteorological data, it doesn't necessarily represent reality, but it helps us to look at some of the extreme conditions that we may see. And typically we're modeling with TMY, typical meteorological year, which is a 30-year. That's a typical type of weather that we're using in energy modeling. So we decided to pick 3 others. So we have the last 7 years, just to kind of see how recent temperature will impact our models, and then extreme weather for 15 years for the hottest days, and then minimum for the coldest days. So for our first run, we used a low-rise residential building, which was selected because it does represent the largest percentage of the building stock. And it also has the most weather-dependent loads with, associated with envelope systems. So here we have a 12-unit building. It was constructed in 2007, 2008, so we modeled it right around that same period of time. So it's a 4-story light steel frame building with brick veneer, and it has a forced hot air and direct expansion AC. And again, we're modeling in 5 locations. For this particular one, we just modeled in Rochester, so we could give you something that you're familiar with in this area. And so we are listing the measures by the highest effective useful life as it relates to resilience and climate change. And just to kind of give you an overview of package minus. So what we're doing is we're starting off with the as-designed building, and we're removing measures one after the other without replacing them. So then by the time we get down to high-efficiency HVAC, you're at a code building with good code systems. So, as you see, going down through, the overall package of measures has a pretty decent savings, almost 30%. And, definitely higher with some of the lower, the systems with lower life cycles, like lighting and HVAC, but it's important to have those in there for energy efficiency and, impact on the grid. And the higher the measures at the top, they're going to be more effective with building resiliency. So you can see the peak impact, summer peak impact and winter peak impact. Those are going to be more related to the measures at the bottom. That's why it's important to have those in there. Fuel use, there's some savings, not quite as high, but we still see some decent savings there. And cost, and then implementation costs. And these are full incremental implementation costs. And so typically these are impacted by some sort of incentive here. They're not. So on to passive survivability, which is second, is just as important as energy efficiency. And so here are some of the measures we saw at the top of the list. They're going to have the biggest impact on passive survivability. And so here we're looking at analysis of indoor air temperature as it relates to, in this case, we're looking at the maximum 15-year max extreme weather file. So you'll see in the as-designed building, the interior air temperature is quite a bit lower than the code building with no measures. The above code hours at 82.4 degrees Fahrenheit, that number is the overheated threshold recommended by the Chartered Institution of Building Services Engineers and converted from 28 degrees Celsius. So we're using that as a frame of reference just to show how many hours each run is above 82.4, because that's the number of hours where it's really not, you're not going to be comfortable. It's probably not survivable for very long. So the takeaway with passive survivability is without utilizing building systems that are resilient to climate change, extreme climate temperatures may lead to higher interior temperatures for longer period of times, which can lead to exhaustion, illness, and the shelter becomes inhabitable. And here with weather variability, here we're running all 5 of our different weather types to kind of show the variation in energy use and interior air temperatures and hours above. So we have our typical 30-year TMY at the top that we normally use in energy modeling. Next down, we have the last 7 years. You don't really see that much change there, at least in this run, but conceivably in other runs you would. Just to move on down here. So moving to the maximum extreme weather data, and this is with the as-designed building. You can see there's a decent increase in electricity use as compared to the maximum in the TMY to the XMY. So same here with the winter use, with winter KW and fuel use, still a decent increase in percentage in energy use. And certainly the outlier here is the hours above 82.4. That's a huge increase in the number of hours where it's just not really habitable anymore. So on to the next steps and our conclusions. So we're going to run the additional building types and additional climate zones. So there's quite a bit of more work to do here. So really interesting to see how that turns out. And with our conclusions, we're going to be looking at some different different strategies in energy conservation measures. All different types of building types, industrial and educational, where you might have a fallout shelter, and so we're going to have some variety here of building types. So it'll be interesting to see those results. And then with the typical meteorological year weather files, they may fall short of extreme weather. So we really need to think about integrating other types of weather files and running multiple weather files to kind of get a better picture of how climate change is going to impact buildings and interior air temperatures rather than just using the historical weather files. And that's it. Thank you very much.
So I'd like to invite the speakers, the 4 speakers who just spoke, to come up and join at the table. We have a couple minutes here before 1:30 to have a question and answer session. Since this is something that's being recorded, if you have questions, just ask. This is an unbelievably close microphone to ask questions from, but there's also one over here. If you have questions for the audience, though, please come up just so we can make sure that we get your audio information. So I just wanted to open up to does anybody have any questions about the presentation that we just had here? Do you want to share? This, by the way, is always what happens to me when I teach in this classroom. So I'm assuming that it's something as part of this classroom, or that everybody's turkey sandwiches are starting to be digested into their stomachs right about now. Nobody wants to do that? We could do that.
This is for Brendan. So in your scenarios, were you considering looking at actual climate predictions going forward rather than just typical years from past weather and meteorology?
Yes, in our, I don't know if this is on. I'll just try to speak up. Yes. We will be looking at, we're proposing looking at extreme weather conditions. What weather analytics is right now is, I don't know if anybody else is putting that kind of data, but that is what we will be looking at. We have extreme weather files for all the locations that will be running. So we'll be using those files for all of our runs.
Is that historical or is that?
Well, we have both. Well, it's, can you talk a
Sure.
little bit on that, Nick? On
Absolutely,
extreme?
sure. So the data that we do have from weather analytics is the extremes that we've actually experienced already to date. And the reason that we kind of chose to go with that data as opposed to climate projections is there's already a lot of error introduced in the weather files and in those locations. It doesn't represent any one particular year. It's this sample kind of average year. So to add the error kind of associated with that kind of file format, in addition to some of the errors that are found in climate models, kind of really builds up, something that may not represent what's happening in the future. We were hoping by using data and things that have already happened in New York State that we could show professionals that this is something that we really need to immediately start to respond to. And because they're built as extreme files, we also get a sense of what the impacts might be on peak loads and things that are important for energy systems in those. I will say, though, that the how you do this type of modeling is something that's being hotly contested right now. So there are some folks who are trying to build energy models that are tied to climate models. There are other folks who are using this approach, and I don't think anyone in particular has settled out yet as being the best approach. But we're hoping that this will be something that will be useful for folks.
This is another question for Brendan. So your modeling there that you showed us was for this newly constructed building. Are you planning to do some modeling on older buildings as well to try and get a gauge of what their quality of environmental or energy consumption is? And I ask this because one project I'm working on right now, we're looking at putting in geothermal, and the geothermal contractor says, well, I have these programs and I can figure out your building, but you got to get rid of all these old windows because that doesn't fit in my model at all. And we've certainly seen a lot of at least anecdotal information that weather stripping and restoring historic windows, and perhaps with a storm panel or something, can give you the same kind of values as a new window. And so to have that sort of thing is kind of a problem.
I'd say, I
Actually,
would say in my
building.
normal work day, that is often what the type of analysis that I'm conducting, is looking at much older buildings and seeing how, how we can improve them. There's many challenges there, like as you had mentioned. This particular research, the run that we just completed, it was on, comparing a fairly new building to the code version of that building, so it would be older. I don't think we have any scenarios right now where we're looking at existing buildings, and we haven't, that would require us either come up with an example or to actually go out and survey a building and determine the existing conditions. But we could potentially, a lot of the energy models, frankly, are new construction that we have, and most models are developed for new construction projects, not typically existing buildings. So that's where that's where the challenge lies. Is we can downgrade a model certainly though to represent an existing building that's very leaky, certainly. But that'd be an interesting, something we could talk about.
Sure.
That'd be an interesting, something we could talk about.
Sure.
Well, I just wanted to add to that. The National Trust for Historic Preservation has done a variety of window studies, and they did it across regions across the country and looked and used eQuest as the model. So, Tony, I can get you the link to that study, which is actually a really good study. NCPTT, which is a division of the National Park Service, funded that. And then there are a variety of people who work in the field. I do a combination of sustainability and historic preservation. And we work with engineers who do this all the time and use eQuest, and there are a couple of
Sure,
other
and I
models.
think the issue of historic buildings is one of the biggest challenges that we'll be dealing with. This is really the first step, and hopefully a much longer engagement on this as a topic. We are starting to see the states and some of the different federal agencies also looking at this and modeling this, but there's a lot to go in terms of digging into it. Other questions? Other questions?
Question of your typical maximum year, typical minimum year seems to be an average over.
You mean the maximum and the minimum, the extreme weather maximum and the extreme weather minimum? So that's over 15 years. So that is I think the maximum values, right, per day, over 15 years. Per day, over 15 years.
Okay, so you wind up with. So you wind up with a single value in that column.
Well, it's per day, so
Doesn't show
because I'm loading the
moving target getting
files
better.
into eQuest. So it is going to be an average of 15. Well, it's going to, because we load in 8760 hours into eQuest, so it's going to be an average, right, from the 15 years. For each day of the 15 years, it's going to be like January 1st. It's going to be the average across the 15 years. January 2nd, the average.
What you hear, though, on the news flashes, last year was the warmest on record, and the year before that was up to then the warmest on record, et cetera, et cetera, et cetera. And so you've got possibly, I'm not a modeler by trade, you have a single value covering.
That's a good
15
point.
years.
Is it?
Understate.
Yeah, so with the extreme meteorological year files, it's taking really those worst days that have happened in the past and building that into the model. All models are approximations. All of them are wrong in one form or another, but hopefully these are useful, and hopefully they start to point at some of the strategies. So our goal is, we can't perfectly predict the future on this, but hopefully in identifying some of the strategies and conservation measures that might be appropriate, we hope that has utility for people taking on these kinds of projects.
Thanks. I want to come back to the historic preservation for a minute, because most of the building stock that we have is likely to be kept unless we are going to do wholesale moving of people, which we may have to do eventually. So some of the building is really historic in that sense, and some of it is just there. We have a lot of it. And I think that is actually problematic, and I'm glad that you're going to take that challenge on, because I think that if we're always talking about new construction, we know that that's nice jobs for architects and engineers, but it's not necessarily where people are actually going to be living. But the other question that I had when I was thinking about your categories is, is there a way of being able to measure somehow the impact of these measures on the biodiversity in the surrounding area? I know in New York City that's probably not such a big deal because you don't want the rats there anyway. But if you think about, other areas and more rural areas, we know that one of the biggest problems that we have is the decrease in the biodiversity, period. And I'm just wondering if there's some way that measure could be included somehow, because in the long run that actually might increase the value of the buildings that we're doing and what is happening overall. So I'm just curious as if you thought about that at all.
So I'll honestly say that that's probably not an issue that we've been thinking about as part of the project. As an assessment, this has been at the 30,000 foot level as a topic. As we get into some strategies like flooding, there are some discussions about how there are less resistive ways of doing some of that work. I don't know, Mike, or if you wanted to talk any more about some of the specific tactics that we pulled into something like that. But
Well, I think the purpose of, with the tactics and having the strategies and describing the strategies and the tactics that fit within, is that you can take the general strategy and apply it to multiple situations, and based on the individual building condition, you can fit whatever tactic you need to your specific building condition or your specific ecological condition, if you will. So if you're someone that lives in, if you live in Western New York and you're experiencing some flooding conditions, you're not looking at something that's telling you need to do this, 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 and this. You're getting a wide variety of options, and you're getting a wide variety of information on different tactics that you could plug in to use in your specific situation. So there's some variability in how you respond and how you increase resilience in even old structures. There are some landscape tactics. So we have there's green infrastructure, there's gray infrastructure. We have like emergency management. There's planning level interventions that we've included within the document. So it's not all building level. We've accounted for a wide range of different interventions. Mm-hmm.
So we have time probably for about one or two more questions. So, Mike.
Question sort of for the four of you. Yasmin mentioned in part of what she discussed the regional differences and what the resilient sort of concerns are in terms of whether it's hurricanes or snow, and some of the other presentations looked at the regional differences across the state. And because New York State has such a wide range of different very dense urban areas versus very rural areas that are very remote. How is the research sort of prioritizing or helping these different regions understand what their priorities should be? Has that been sort of thought about as one of the outcomes of this?
So I can say just broadly, and maybe we can have each of the individual presentations talk about it. Every single part of the project has broken this down at a regional level. So we've tried to look at some of the regional differences, among each of these areas of New York State. And so within that, we have energy modeling results, we have economic modeling results, and hopefully that starts to give them a clearer picture of what's happening, in each of these different locations. I will say though that, from looking at the different regions, the way that New York State does that from an economic development standpoint is different from how Climate does it, so these again are kind of all imperfect representations of reality, but the hope is that people can start to find information that's relevant to what they do in that work. And maybe turn it over, if each of you had a quick thing that might be related to what you're doing, or?
Yeah, well, I can start with, from the perspective of the Resilient Strategies document, and also from like the vulnerability mapping, and then maybe even with some of the economic information, is through this research we can make this information accessible we can put it out there and we can say, here's the things based on this study, based on this analysis, based on this data set, here are the things that are impacting your region of New York State, and based on some of the analysis that we've done within the research project, here are some of the ways that you can respond to those specific impacts. So again, from the Resilient Strategies document point of view, is we've attached strategies with some specific hazards that we've derived from the Climate report, and we've associated those hazards with specific regions in New York State. So you can kind of pick and choose how you navigate through the document and apply certain tactics and strategies to your specific situation.
And I think the integrated assessment that we're working on also complements what Mike just talked about, is we're trying to guide people, and here's what the literature says in terms of the impacts that you will be facing in the region that you live in. And here, in terms of input from the stakeholders, here are what professionals like yourself are saying about what's happening and what their experience. So it's more of a guidance into what you're going through, where you live and your profession, and then we let people take what they need from that guidance.
I think at the state level, state policy level too, I think that economics kind of hopefully shed some light on the capacity that some of the rural regions have, rural and Adirondacks wilderness regions have. They may not have local capacity to deal with mitigation or recovery the way that, say, the western or downstate would be able to recover. I think that's very important to understand that at the state level, that there are different challenges in those regions, and they don't have as robust economies and people in place to deal with those things. So if they're not aware of that yet, I hope this sheds some light on that.
Yeah, so from the design and building community, just hoping from our results to show that there's, different approaches to analyzing, calculating loads for buildings, and you need to really have a little bit more foresight about climate change and how that's going to impact resiliency of buildings in the future, and on the type of construction that should be considered.
I want to thank each of the four speakers for doing a great job with their presentations. Just a reminder that we have continuing education units available for all the professionals in the audience. So there are some sign-up sheets that will be outside the table there. And also for the students who self-identified, whose work is out here, we would love it if we engaged in the breaks coming up on some discussions of some of the work they did, because it's really helped this project out quite a bit. But again, they're the future practitioners looking at these issues. We'll be taking about a 25-minute break, so please come back around 2 p.m. for our next session that Martha Baum is moderating. So thank you very much.